part of the notes is about this graph, and this will help you with the questions that you have on this um, double-sided worksheet that you have of graphs. Here's one page, here's the other side, and I know it might be a lot of what you guys probably understand already about going through the phases, gas and liquid and solid. You'll see a slanted lines when you're in one state, but then you'll see um, flat lines when you're going through a phase change. Each of these flat-lined areas is a phase change, where the slanted lines are going to be staying in one state of matter. So when we look at the note sheet at the very bottom of the second side, you'll see an example here, and I wanted to just walk you through it, or at least see one already completed, with me not having, I'm not standing by the smartboard at the moment. So as you look at this example that I've written out from another class, is that this first area is a solid, the middle area is a liquid, the top area right here is a gas, and as you go through the flat line areas, there's no change in temperature, so you're melting on this bottom line, and that would be considered its melting point. You're going to be boiling at the top line, and that would be considered its boiling point. And if it's marked at 0 and at 100 for Celsius, then it would be considered water. Now, if you see other temperatures in Celsius, then it wouldn't be water. The other name of this would be a heating curve, because you're heating it and it's an endothermic process. You're giving, and it is absorbing energy with the positive joules. The other part about what we're learning right now is that we have a change in temperature when you have the slanted lines. That's the slope, the change in temp, because you're changing the temp with time. So when you have any change in temperature here or in the middle here for liquid or gas, you're going to be changing temperatures. You're going to do this equation that we were doing on the quiz last week with the mass, the C, and the change in temperatures. Each chemical has a different constant. You could have different temperature changes in the liquid, different temperature changes in the gas, different temperature changes in the solid. But that's a visual, qualitative understanding of what that math is all about. Then if you do a cooling curve, sorry, my word here is not all connected, but you see the word cooling here. The cooling curve, you're going to go from gas to liquid to the solid. It'd be exothermic. It would have a negative joules, and you would be condensing and freezing, as I've written here. Again, you'd have a freezing point and a boiling point like before, but this flat-lined areas is no temperature change, so the math would involve the heat constants, the enthalpy constants, based on freezing and fusion, or condensing and vaporization, timesing it by the mass. So the flat-lined areas, you only use this kind of math. On the slanted areas, you'd use the other kind of math from last week. So when you look at these example here, try to fill that in on your paper. And then when you go to the questions here on this page, you have all these questions here, asking questions about the four graphs, answering them. Notice that when you have all three states of matter, you're going to have two flat lines. If you just have one flat line, you don't know what the state is, you have to kind of read it in the question. And when there's no flat line, that means it's just one state. This would just be a liquid for graph D. So hopefully this gives you a basis to help you with these questions, in that you could probably get these done by Monday, and we can go through these questions on Monday, and then hopefully get a start of the homework, the math homework 2, on Monday. Now there's two sides to the math homework. I did talk about this set of problems on the previous video, and then I never actually looked at the second page of the homework. But here is the key for the answers there for you guys. Go ahead and write those down and use them, with the answers for those questions here. This is the answer for question 1, for question 2, the, the change in temperature answer, and what the final temperature would be for question 3. And then for the first 3, 4, 5, and 6 of the bottom 3, and then I can let you know what the new question 7 answer is. I just added that in, but after I wrote this questions out from last year. So whatever this area here, you can use to help you confirm if you understand all this math here. These first 3 are what we quizzed on last week. These bottom 3 are new equations. Note that they're talking about methanol melting, ammonia condensing, and the joules involved here for ice melting. work on those three along with these top three, and we'll clear it up on Monday. Have a great weekend. See you then. Bye bye.